1. Okay, this first slide, we basically just did this in the activity. Okay, so this is just sort of to be a refresher. How do you find the halfway point between two numbers?
Isn't that the bigger number subtracted from the small, with the number?
That's to find the distance between the two. How do you find the halfway point?
You do the x value plus the other x value. And then you do the y value plus the other y value. And then you divide them both by 2.
Okay, yep. Now this first question is just asking you about single numbers. So for just single numbers, you would just add the first number. Oh, I don't want to use x, because that'll get confusing with the coordinates. Okay, I'm going to use a. So for this, you would just add the two numbers together, divide by 2. Okay. To find the halfway point between two coordinates, so that's when we start talking x and y values. That's what Travis just said. Okay? And actually, I'm not going to bother writing the formula here because it's on your next slide. Okay? So the midpoint formula, if you have two coordinates, and remember when I say x1, y1, and x2, y2, that just represents two different coordinates. So this might be 5, 7, and this might be 12, 2. Okay? It's just two different coordinates. This is what the formula looks like. x1 plus x2 divided by 2, y1 plus y2 divided by 2. Again, I show you this formula just because it's the easiest way to write it, but please do not stress about memorizing the formula. I want you to memorize the process, okay? All we're doing is adding and dividing by 2 because that's finding the halfway point, okay? So I'm adding together the x's and dividing by 2, adding together the y's, dividing by 2, and writing my answer back as a coordinate. Okay, are you good on that process?
Yeah.
Let's try a couple without a graph. So if I wanted the midpoint between 2, 5 and negative 4, 8, what two numbers would I add together first? Kyle, in the back, what do you think? What would I add together first?
What?
Yep. In this bottom left example, if I was trying to find the midpoint, which two would I add together first? I guess you could. It doesn't really matter what order you add in. I was going to say, I think you're thinking slope where you have to do the y's first. This you're finding two separate numbers, so it doesn't matter which one you do first. If I do 2 plus negative 4 and divide by 2, that gives me, let's see, 2 plus negative 4 is negative 2. And then negative 2 divided by 2 is negative 1. Isaiah, can you have a seat, please?
Yeah, sorry.
Thank you. Now I'm going to do my y values. So 5 plus 8, and then divide by 2. That's going to be 13 divided by 2, which is 6.5. So then to write my answer, I'm just going to take those two numbers and put them back in a coordinate. Negative 1, comma, 6.5. Easy, right?
Yes.
Really easy?
Yeah.
Okay, let's try the next one. What two numbers do you want to add together first? Okay, negative 10 and 10. So negative 10 plus 10. Don't let that freak you out that it's equal to 0. That's totally okay. That equals 0. Okay, because negative 10 plus 2, I'm sorry, negative 10 plus 10 is equal to 0. And then 0 divided by 2 is still 0. Then what am I adding together?
Negative 4, negative 3.
Okay.
Is that negative 7?
Negative 3 plus negative 4
Or is
divided by 2. That is negative 7. Yep. Whoops.
So the coordinates would be 0, 3.5.
Yep. This is negative 3.5. And so then my coordinate would be 0, negative 3.5. Okay, that would be your midpoint.
Wait, for this one, do we have to do it backwards now?
What do you mean?
For the midpoint connector theorem, do we have to
Nope.
do it backwards?
Nope, that's something totally different. Everyone good with those examples?
Yeah.
Everyone think if I gave you like a page of 50 of those as homework tonight, you could fly through them really quickly?
Probably wouldn't do them, but.
Okay. But you would know how?
Yeah.
Okay. I'm not. Okay, the midpoint connector theorem. We're going to go back and talk about triangles some more because I know you love triangles. Okay, and this will make you feel like you're back in geometry class.
I know
Okay.
it's small.
The midpoint connector theorem. In a triangle, the segments connecting the midpoints of any two sides. So for example, if I took the midpoint of this side and the midpoint of this side, so these two dots, and I connected them. I'm connecting midpoints, therefore this is the midpoint connector theorem. That segment that I draw is going to be parallel to the third side, and also half the length of the third side. Okay, give you a minute to write that down, then I'll show you what that means. Okay, so two things you know when you connect in a triangle the midpoints of two sides. That segment that you draw is going to be parallel to the third side and half the length of the third side. Okay? So in this triangle, for example, if I connected those two sides, that means that this, let's pick a good color here. This segment here is going to be parallel to this line down here. Okay? And it's also half the length of that side. So this side down here is 19. What's the length of this side?
Oh, that's going to be 9.5.
9.5, yep. Okay? I could do that anywhere else in the triangle too. Let's say I drew in that side. Okay?
Wait, is that half of 14?
Yep, that would be half of 19.
Half of 19?
Mm-hmm.
Oh, yeah. Yeah, I got it.
Good? Okay. So this segment here that I just drew in is going to be parallel to this one. It's always parallel and half. Guys, are you listening?
Yep.
It's always parallel and half of the side that it's not touching. Okay, which would make sense since it's parallel. Okay? So this is going to be parallel to this one over here. And what is the length of this one going to be?
7.
7, because it's half of this. Okay, so this is 7. Okay? That last one in, that's going to be parallel to this one up here. Darnell, what would be the length of that side?
Not sure.
Well, we know it's half the length of the side it's not touching. So we've got 14, 19, and 8. Out of those three, which two is it not touching? So what did you say? 4. Good. So this length would be 4. Okay. Nick?
Is that your triangle in there like a third of the big triangle one? Or?
It's actually a fourth of the big triangle. Yeah, good thinking with that. Yeah, the size of this triangle, we could prove this, and actually there might be something similar to this in your homework. But see how this divides it into like 4 different triangles? All 4 of those triangles are congruent. Okay? Because you know that like this is equal to half of that, so these two sides would be congruent. This is equal to half of that, so these two would be congruent, and then this would be equal to, well, in that triangle they're the same side. But so yes, good thinking with that. One more word to throw at you. If you draw in all 3 of them at once, that's called the medial triangle.
Is that half of every single
Okay.
one?
Well, yeah, I mean, these 3 side lengths would be half the lengths of these 3 side lengths. Okay? But that's kind of what we were just talking about. That medial triangle is going to be congruent to these 3 triangles on the outside as well. Okay? Now, there are going to be some problems in your homework that ask you things like, now pay attention here because I'm about to tell you something that's on your homework tonight, so you're not stressed about it. On your homework tonight, there's going to be questions that say something like, prove that this, can you see what I'm outlining?
Yeah.
That this is a trapezoid.
Uh-huh.
What does something have to be a trapezoid?
2 parallel bases.
Okay, so how do we know that this has 2 parallel sides?
We cut our drop on the thing is parallel to the
Okay,
third side.
so we know that this is like an easy 2-step proof. Ready? We know that this side is parallel to this side because of the,
Midpoint connector theorem.
thank you, midpoint connector theorem. That's what tells you. The midpoint connector theorem tells you they're parallel. Now that I know 2 sides are parallel, how do I know it's a trapezoid?
Because both the bases are parallel.
And that's what a trapezoid is, right? So I justify it by saying the definition of a trapezoid. Perfect. Okay. There are some other questions it could ask you like that. Like it could ask you, shh, guys. It could ask you, why is this a parallelogram?
Because that's
Right?
the parallel side.
Because we know these are parallel because of the midpoint connector theorem. We know these are parallel because of the midpoint connector theorem. Therefore, this is a parallelogram by definition of parallelogram. Okay? So the proofs that you're going to hit in your homework tonight should not be hard. I'm going to put this video up over the weekend. Okay, actually I'll put it up today, but it'll be up there over the weekend while you're diligently working on your assignment. When you hit those questions, do not read them, freak out, and then say, no, I can't possibly answer that question. Look back at this video. Right at the very end, I just went over that, okay?